In this video, we will look at radioactivity topic MCQs and try to explain how to attempt them. Number one, which type of radiation consists of electrons? It is beta particles. Number two, a sample of radioisotope produces count rate of 10,000. Half-life is 1 day. What was the count 2 days ago? Well, if you go back 1 day and double the 10,000, it becomes 20,000. Go back another day and double the 20,000, that becomes 40,000. Very simple way of doing it. So number three, when it emits alpha particle, the proton number should decrease by 2. The nucleon number should decrease by 4. So A is the choice. 3 types of radiation in order to the ionizing. So alpha particles are maximum ionizers, then beta, and then gamma. Half-life is the time it takes for the number of nuclei to decrease by half. That's by the definition. Number 6, continuously uses plastic sheets. So we will need a beta source because beta can pass through the plastic sheets, and it should have half-life of 7 years. So why we need beta particles when they can cross the sheets? Well, when the required thickness is not met, the count rate will be different, and that can be made to stop the production line. And the count rate means if there is a thick plastic sheet, the count rate will decrease. If there is a thinner plastic sheet, the count rate will increase. In both the cases, this can be used as an activator to stop the production line of the plastic sheets. Number 7, so we have a radioactive sample. There is 20 counts without the source. Initial count is 520. So what happens after 2 half-lives? So we go 500 to 250. So first of all, take the background. So it gives you 500, then 250, and then 125, and then add the background because you are asked about the count rate, not the number of nuclei. So it will be 125 and 20, 145. So D. Decays by emitting alpha particle and then beta particle. We've done this in nuclear atom. So if you work it out the same way, it is this. Number 9. So from 720 to 90. So from 720, step by step, 720 at 0 hours, 360 after 24 hours, 180 after 48 hours, and 90 after 72 hours. B is the correct choice. Number 10. The electromagnetic radiation, the only one produced during a radioactive decay, is gamma rays. Alpha, beta are not electromagnetic, and X-rays are not produced in radioactive decay. We've done this many times. Number 12. So C614. What two quantities decrease to half? So the number of nuclei and the decay rate will decrease because when the number of nuclei are less, its decay rate also decreases. Number 13, electrical charge is positive, so consider B and D, and they can only travel a few centimeters. Number 14, same question, but for beta particles, they are electrons and they can travel a few meters. So it can, the nearest choice, the nearest match is 10 to 100 centimeters. So electrons are beta, helium nuclei alpha, and electromagnetic is gamma. This is a tricky question. So we have this much number of nuclei of carbon 14. 5600 year is the half-life. So after this much years, look at the starting count, and then we can see that step by step, each time halving the number of nuclei. Don't bother about the 10 power 16 because it is given in the answer. Bother about the number, whole number. So it will be 9 to 4.5 after 5600, and then this after 11,200, and then this after 16,800 years, which is the required. So it becomes 1.12. Look for 1.1. It is here and here, but this is not possible because this number is not actually halved. If how can you verify this? Well, if you divide this by 2, you get 4.5 into 10 power 16. You don't get 4.5 into 10 power 8. So that's why B is the correct choice. Number 17. So photographic film badge is used and it detects gamma and beta. Why? Because alpha particles cannot pass through the photographic film. So the marks on the photographic film will show how much radiation has the person been exposed to. And if it reaches a certain limit, they shouldn't be allowed to enter the premises. This is how the photographic film system works. So everyone working at any nuclear station or lab wears this badge on which there is a film, and the film is every time the person enters the premises, the film is examined by someone at the security gate, and they check the exposure. They have the guidelines, they know how to check it. So when they see a certain amount of film is dark due to the gamma and beta passing through it, they will not allow the person to enter. Alpha particles, its nucleus. Well, we know alpha particle means we lose two protons and two neutrons because the mass number or the proton number, sorry, the atomic number, which is also the proton number, decreases by 2, and the mass number or the nucleon number decreases by 4. 2 plus 2, 4. Number 19. Well, asking about background radiation, and it is present always, even when there is no source. So B choice. Number 20. It falls from 4,000 to 500. So this is the working, how it goes: 4,000 to 2, 2 to 1, 1 to 5, 1, 2, 3. So it's three half-lives. So 72 minutes divide 3 means half-life will be 24 minutes. Look at the mechanism, the method of working half-life in this form of questions. Remember this, practice this. Alpha particles are positively charged and their ionizing is strong. Alpha particles pass through electric field or a magnetic field. How is the path affected? In both they are deflected. In electric field they are deflected, so do in magnetic field because they are charged particles. They experience a force. So a nuclear fission produces smaller nuclei, breaking the larger one, and fusion makes a larger nuclei, and this is the energy source of a star. But in both cases, what is common? Release of energy. Whether you break down a larger into smaller or you make a larger from two smaller nuclei, you get energy. Count rate of a radioactive isotope. Well, it decreases by time and it's not a constant rate. So reject C and D. It's not constant. Reject B. The only one is A. Why it is not constant? Well, it is a random process. It can happen anytime. It might not happen sometime, and sometime it might happen more. But it continuously happens, but at a variable rate. Number 25, carbon 14 is used in dating of ancient bones because it has a very long half-life, 5,600 years. So that can be used to calculate how old a bone is. What are the dangers? Well, beta particles can pass through skin. Yes, why B, C, D, and D not applicable? Because, look, material that emit only alpha particle must be kept in thick lead containers. No need for this. Alpha particles can't even pass through paper. So if you have a paper, you can stop alpha particles. Radioactive materials are able to handle after two half-lives. No, that's a joke. Sources of gamma radiation are dangerous because they have long half-lives. That is also another joke. This is not true. Isotope X, 4 years, contains 8,000 atoms. After how many years? It will have 1,000. So go step by step: 4,000, 2,000, 1,000, 0, 4, 4 to 8, 8 to 12. So 12 is the choice. Dispose large quantity safely by burying it under a dry rock and deep, very deep. That's the only way you can dispose. You can't burn it. It will be actually disastrous to burn a radioactive isotope. So will it be if you drain it down or put it into a river. The count rate goes from 400 to 50 in 12 minutes. Same method. Go down how many steps by halving each time and then divide that number by the total time it has taken, gives you the half-life, 4 minutes. So fill in the blanks. One is fusion. Second one is joined together. This is the definition of the nuclear fusion. 51, we have two samples. We have a plastic sheet and a metal sheet. Beta is stopped by metal sheet. Plastic stops only alpha. So what's the question? Well, we can distinguish beta only because it is the beta that has been stopped. Shall we explain it in a different way? Well, we want to know which type of radiation is coming through. We place a plastic sheet, it stops alpha particles, but we still get the radiation. And then we place a metal sheet. So what changes from plastic to metal is that beta particles are stopped. So it is the plastic and metal can distinguish beta particles. Background is 10 and count is 410. So that means we will be subtracting 10 from 400. Half-life is 5 days, so 3 half-lives. 15 days means 3 half-lives. So go down 3, 1, 2, 3. And that means background plus added. So it is 50 plus 10. 60. 60 is the correct choice. Tritium, 12 years half-life. So after 12 years, from 40 million atoms, it will be 20 million atoms. Half-life has gone, number of nuclei becomes half. Definition of the half-life. So half-life of 13 days, sample is kept for this much. Which quantity halved? We've done this before. Number of atoms will be halved. Why B, C, and D wrong? Number of proton, neutron, and electron do not decrease. So we have a radioactive source, and there is a 10 centimeter separation. There is the detector. The question says, which particles are deviated towards the radioactive source in the presence of a magnetic field? It will be beta particles, because gamma particles are not reflected in a magnetic field. They will go from here, they will go straight. And alpha particles cannot travel this far. They come few centimeters in air, so they will never reach here. They will be stopped here somewhere. So the only beta particles will reach the detector. And why they will be bending? Because of the presence of the magnetic field. This is repeat. Count rate from 1200 to 150 in 3 minutes. Calculate the half-life. Same method. Go step by step. 1, 2, 3, and then divide 3 minutes by 3 gives you 1 minute half-life. So this is a tricky question. Sample X has 1 day half-life, 2 has 2 days half-life. They both have this much at the beginning, number of nuclei. So we go step by step on both. 8, 4, 2, 1, 5, 250. Second one goes after 2 days, so stays 2000 first day, second day it becomes 1000, third day same 1000, number 4 becomes 500, number 5 stays 500, number 6 becomes 250. 250 is equal, so they both have same number of nuclei after this much days, 6 days. That emits only alpha particles. Without any source, detectors show a low reading. Thick cardboard are placed. What is the reading on the detector now and why? It should still show low reading because of the background radiation. Because the card means alpha particles are blocked. Source emits alpha, beta, and gamma. Guyton Marsden and Hube and Counter detect the emissions, pass through a thin sheet of paper and a strong magnetic field. So we have a sheet of paper from this source, and then we have a magnetic field. What is detected? Well, you can see gamma, no need to go up, will go straight. Alpha will be stopped by the paper, so only beta. Number 41, we have repeated this question. So, graph shows a decay curve. Why it's not smooth? Because of the random process. The radioactivity is a random process. 6,000 years is the half life. How much time would it pass? The sample falls 1/16th. So go like this from 1 to half, and then half of half, and then half of half of half, and then half of half of half of half. 1/16th. That means 1, 2, 3, 4 half lives. So 4 times half life will be 24,000 years. Travel in straight line is gamma rays. A brain cancer patient should get a beta K because beta is a very good source for attacking the cancer cells, and it shouldn't be very long half life because you don't want to have it there for a long time because it can also cause cell mutation. We can't use alpha, alpha can't even go there, and we can't use gamma because gamma penetrates and it might actually penetrate and it might actually cause further cancer. So it is by the definition, at least one form of radiation is the correct choice. Let's see why A, B, C are wrong. Absorbs than the nucleus? No. At least one form of radiation is absorbed? No. Always splits? No. They're all wrong. Decays by emitting beta particle. How many protons and neutrons? So after 37 with the beta particle, protons become 38. Reject A and B, and the neutron should become 87 minus, sorry, 86 minus 87 minus 38. This number is not affected in beta decay, so 87 minus 38 should give you 49. Why 38? Because of the beta decay, 37 becomes 38. And neutrons are calculated by subtracting the mass number, i.e., the nucleon number, from the proton number. For all radiations, they ionize gases. Why A, B, C, and wrong? They emit light? No. They're deflected by electric fields? Gamma is not. They're completely absorbed? No. Gamma is not. So we have a source, we have magnetic field, and beta particles will be, to be honest, detector is placed at a curved path. So why we will only receive beta particles? Why not alpha? Is because beta and alpha are opposite charges. So if beta goes up, alpha should go down. They won't go towards the detector. Detector does not attract these particles. It only detects them if they reach it. Beta will reach it, alpha will not. Gamma goes straight anyway. Sheet of paper, 30 centimeter detection. There is no difference in the count rate, even though he has moved the sheet. Well, that is because, look, you are checking alpha particle emission and you have placed it 30 centimeter away from the detector. That is too long for alpha particles. They cannot travel that much. So you place the sheet or not, you will not get alpha particles to the detector, so the count rate will not change. Yes, the radioactive source is too far. So number 51, half-life 2400, sample is 720. How long will it take to go 90? Go 720 to 3 half-lives. 3 multiplied 24 gives you 7200. Yes. 742 is the count rate, and it's placed 3 centimeters. 3 experiments. We have a thin card. The count rate falls down to 273. We have an aluminium foil. The count rate stays there. We have a thick lead. Count rate falls to 78. That means we have alpha particles and we have gamma particles. We don't have beta here because aluminium foil should stop beta, but the count rate should go down, but it doesn't. That means no alpha particles. Sorry, beta particles. So we have alpha and gamma. Nuclear fission is this one. You should know this. This is the only possible equation from these of nuclear fission. This is fusion. This is radioactive reaction. And this is another radioactive reaction. 24 years of half-life. After 72, it will be, so 1 half-life, 1 over 2, 2 half-lives, 1 over 4, 3 half-lives, which is 72, it will be 1 over 8. 55, comparison of penetration and ionization. The ionization is alpha, look for alpha first, and then go for gamma, because that has the maximum penetration. Okay, very nice question here. Very nice question. It demands lots of intuition if you get it by a surprise. If you have practiced it here with me, you shouldn't be worrying. So the question says we have a potentiometer, we have a potential divider, sorry, we have a potential divider circuit, 3000 ohms resistor here, thermistor here, and we want to measure the voltage across thermistor. But the question doesn't end here. The question says, look at the graph and tell what temperature will it be. So this is the temperature axis, this is the resistance axis. At what temperature will the output voltage becomes 2 volts? So how I have worked it out is like this. So the voltage across thermistor decreases if it's R. Well, that is for any resistor, that if you decrease the resistance, the voltage across it should decrease. And a thermistor, if the temperature of the thermistor increases, i.e., the temperature of the surrounding increases, the thermistor's resistance will decrease. And this is shown by this graph. So we used the V out is equal to V in times R2, R1, R2. R2 is resistor, LDR, sorry, and R1 is the fixed resistor. And we have inputted the value we know. So 2 is output required, 6 is the input from here. R2 needs calculating. How much will be R2? And 3000 plus R2. So do this mathematical algebraic equation manipulation to find the value of R2 and you get 1500. Go on to the graph and 15, place a dot on 1500. So 1500 is middle between 1000 and 2000. And go down, what you see the temperature is 60. So at 60 degrees centigrade, the LDR's resistance will fall down to 1500. So its voltage will give 2 volts output. Thank you. Well, there is a table showing, and we have to carefully understand what's going on. When there is no barrier, when there is paper, when there is aluminium, when there is thick. Alpha particles only. Well, if it's only alpha particles, without the barrier, the reading is 200. Well, it can be 1200, no problem. But look, without the barrier, it's 200. But with the paper, it goes down to 30 and then stays 30. That means only alpha particles which were blocked by the paper. Now look at this. Yes, we can't and no, we can't accept A and D because in both the paper did not bring the count rate down. We can consider C, but look, it is decreasing the count rate after paper, but also decreasing after thin aluminium and after lead. That means this source has all three radiations. We want to have a source with only alpha radiation, so we will treat answer B. So we have two radiations, P and Q. As you can clearly see, P is going straight, so this is gamma, because that's what it is asking, what is P and Q. So look for gamma, look for C and D only. Now, whether Q is beta or alpha. Okay, look at this working, this reasoning. We can treat beta as electrons, and we can apply the right hand rule. Now, if you remember, we used left hand rule for motor to know which direction will it give you the thrust, i.e., which direction will the coil move. And we had our three fingers THC, thrust, field, TFC, sorry, thrust, field, current. Now in this, we use the left hand LMRG, left hand rule for the motor. Because of the current and electrons travel in opposite directions, we can use the right hand rule. So if we use the right hand rule, place our hand into the, so our first finger should be towards the screen, and place our um, third finger downwards. Place our third finger downwards. Place our third finger. So we have the electrons coming from the left side. So place our third finger in the left, from left to right. So you will see your thumb will point downwards. Okay, so that means I think we're getting confused here. So let's start over. First of all, we should use the right hand rule. Electrons travel opposite direction to the current, so the electrons should go up. Why electrons should go up? Because when we use the right hand rule, place our hand into the paper and place our thumb into the direction where the thing is coming. Yeah, I think there is a little mistake here, because when we use the right hand rule and place our third finger in the direction from left to right, our thumb should be downwards. So downward thumb represents the downward motion of electrons, and that's why the Q is beta. It is not alpha. So we will say that P is gamma and Q is beta. This is wrong. The electron should go down, does not go up. Let's do it again for a clever, good understanding. So we have a magnetic field into the page. So we use right hand because it's electrons. So we place our knuckle first finger towards the screen. Okay, now the third finger should be pointing to the right because the beam is coming from left to right. So we place our third finger from left to right. That will put our thumb in the downward direction. So that means what we are using our hand for is electrons, which is beta particles. If this arrow was up, we would still be using the same right hand rule, but if our thumb shows down and the arrow, i.e., the deflection was up, that means it was going to be alpha particles. Remember this very, very carefully. And this one is a tricky question again. So we have a count rate and time graph. And the question is saying that we have these four different radioactive nuclei with their half-lives given. And the question is asking from the half-life shown, which was the decaying radioactive nuclide? So what was this? Which one was this from these four? First of all, start at the starting count rate. It is 66, approximation 66. Go down to half, 33. Check for the time. It is 48. 48-second half-life. Go up and check. The nearest is 52 seconds. So radon or Rn is the nearest. So radon is the radioactive nuclei for which this graph is plotted by the software. Two possible dangers are that we have done this before. Repeat question. Fission reaction. Uranium-235 is bombarded by neutron to split into daughter elements. 2 minutes. So after 4 minutes, it will be 1/2 times 1/2 will be 1/4. So we have thickness. If the sheet is too thick, source of alpha particle is not used because all alpha particles will be stopped by the paper. You have a source here, paper here, nothing will reach here. That's why we don't use alpha particles. X, Y, and Z are radiations. So read through the details, and we should know that X is gamma, Y beta, and Z alpha.